This is Learning Assessment Problem 1016. The problem-solving strategy here is working with circuits containing ideal transformers. The problem requests us to determine a voltage VO appearing across a 2 ohm resistor on the secondary side of this circuit and suggests that we transform the primary side of the transformer circuit to the secondary side. Let's label some quantities and items on this diagram. Label the primary and secondary sides of the transformer. We'll consider a current I2 flowing in the secondary loop, and eventually we'll use that with Ohm's law to determine the voltage V sub O. The turns ratio N for the transformer is equal to 2. Let's label this voltage source on the primary side V1, and we'll have an impedance seen looking back into the primary side Z1, and then looking into the secondary side of the transformer at that primary side we'll have the impedance Z2, and likewise we'll have a voltage V2 across the terminals of the transformer on the secondary side. Since the V1 and V2 labels for voltages both appear to be positive at the dotted terminal, we'll have the relationship for the voltages V2 is equal to the turns ratio N times the voltage on the primary side V1. And for the impedance transformation, we'll have that the impedance Z2 seen looking into the secondary terminals of the transformer is equal to the square of the turns ratio times the impedance on the primary side of the transformer, Z1. And finally, let's label some terminals on this transformer. Call this upper terminal X, the lower terminal Y. Applying the voltage and impedance transformations to this specific problem, we'll have V1 is equal to 12 at an angle of 0 degrees volts, and therefore we'll have that the V2 equivalent transform value is equal to 2 the turns ratio times V1, which is equal to 24 at an angle of 0 degrees volts. For the impedance, we have on the primary side Z1 is equal to 2 minus J2 ohms, and then this will transform to the secondary side as Z2 is equal to the square of the turns ratio, which is 4 times this 2 minus J2 ohms, which is equal to 8 minus J8 ohms. Now we can draw the transformed equivalent circuit. So here we have the 24 volt source, the 8 ohm resistance, and the J8 ohm capacitive reactance, which were transformed from the primary side of the transformer. The X and Y terminals are the secondary terminals of the transformer, and then we have the circuit elements on the secondary side, the 4 volt source and the 2 ohm resistor, and finally the current I2 and the voltage VO represent the quantities that we're interested in. So now we can solve for the current I2 in this loop circuit. I2 will equal 24 at an angle of 0 degrees volts minus 4 at an angle of 0 degrees volts, and then divide by the total impedance in that loop, 8 ohms minus J8 ohms plus 2 ohms. This is equal to 20 at an angle of 0 degrees volts divided by 10 minus J8 ohms, which is equal to 20 at an angle of 0 degrees volts divided by 12.81 at an angle of minus 38.66 ohms. And the value for the I2 phasor is equal to 1.562 at an angle of 38.66 degrees amperes. Now we can use that to determine the voltage V sub O by Ohm's law is equal to 2 ohms times this current I2. That is equal to 2 ohms times 1.562 at an angle of 38.66 degrees amperes, or V sub O is equal to 3.123 at an angle of 38.66 degrees volts.